We present a method to apply generative diffusion models to interactive texture painting on 3D objects. Unlike existing texture painting systems, where the same image is repeatedly stamped over the surface, our method allows painting of any complex texture with variations and seamless tiling. Any inspiration photo, even of lower resolution, can immediately become an interactive texture brush with no training or pre-processing. We can even generate a seed texture using text-to-image diffusion. During an interactive stroke, we cast a ray from the cursor through the mesh and use normal and previous position to orient a local camera pointing at the mesh. The local patch rendered from this camera becomes a conditional input to an inpainting image diffusion model. The output of this generative model is then back-projected into the texture image using standard UV mapping. This process repeats for every patch of the painted stroke. Because diffusion supports inpainting, this allows generation of local patches that tile seamlessly with the texture already painted. Applications of our method include rapid 3D concept design. For example, prototyping a fantasy garden and exploring gingerbread house looks. Notice that patches tile with each other naturally, with no user-defined alpha maps or manually painted transitions. Designers can develop bold fabric prints, for example, using these painting inspirations. It is also possible to complete this realistic photogrammetry asset using forest textures sampled from photos captured in the wild. Notice how seamlessly different bark textures transition to each other. Or, we can source textures from this physical toy to develop a similar look on a different 3D toy. Notice how different yarn patterns are melding together. Beyond generating RGB textures, we prototype a multi-channel material decoder that allows painting additional PBR material channels, such as normals, roughness, and ambient occlusions, which result in more realistic rendered appearance. We piloted our system with 2 professional 3D artists who found our tool easy to use and created realistic blending effects usually time-consuming to achieve in the existing software. Our method shows that generative AI models can be integrated into highly interactive artist-driven workflows, where the artist holds the brush. We hope to inspire more work empowering artists with interactive and controllable AI-driven tools.